Fine. So this is the problem we are going to start today. A card is drawn from a pack of 52 playing cards. What is the probability that it is? We have five options. So out of that, the first one is, what is the probability of getting a heart card? And the next is, what is the probability of not getting a heart card? Then either it can be a club card or a red color card. It can be a queen card or a diamond card. Then it should not be a spade card. So we have five possibilities that are given, and each of them should be separately considered and solved. Okay. Now, like the previous question, here also we will be defining the events separately, and then we will be solving the problem. Okay, so what is the basic understanding of the cards? There will be 52 playing cards which will have four separate options. So you will have spade, club, hearts and diamonds, where spade and club are black color cards and heart and diamonds are red color cards. Each card will have a set of 13 cards. Each set will have 13 cards in them. Okay, each set will have 13 cards in them, and the numbering of the cards will start from A 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then J, K, Q. Sorry, A 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 1. You will not have 1. Okay, 9, 10, and then JKQ. So totally 13 cards will be there in each set. Okay, so this is the basic understanding of the 52 playing cards. Now let us define the event as per each question. So let's read the question once again. A card is drawn from a pack. A card means only one card is drawn from a pack of 52 cards. So what is the probability that whatever that card which they drew, that should be heart card? Now how many heart cards are there in the pack? Okay, total number of cards are 52, but the heart cards are 13. Okay, so the first event is, let capital A be the event of drawing a heart card. Okay, event of drawing the heart card, that is event A. So probability of getting a heart card is equal to probability of A. This is the event A. Now what is the event A? Event A is drawing a heart card. So how many cards do we have? We have total 13 cards, 13 heart cards. Now out of 13 heart cards, we can select any one card. So the total possibility of selecting one heart card out of 52 playing cards is 13 by 52. We have total 13 cards out of 52 cards. So out of 13, you can pick any card. Okay, so that is the first event of drawing a heart card. Understood the first question? Clear? Understood the first question, or you want me to repeat it again? Reply quickly. Next. Next question, not a heart card. Now let us read the question once again. A card is drawn from a pack of 52 playing cards. What is the probability that it is not a heart? First one, it is a heart. Second one, it is not a heart. So if A is the event of drawing a heart card, now for not a heart card, I can take this as A dash or A transpose, right? So if this is event A, this should be the other way around, right? So A dash is the event of drawing not a heart card. Except heart card, we will draw other things. Okay. Now, how do we solve such question? Probability of not drawing a heart card is probability of A dash is equal to, we know what is probability of A. So 1 minus probability of A, okay, 1 minus probability of A will give us probability of A dash. So that is what we have done here. 1 minus probability of A will give us probability of not drawing the heart card. Okay, so which is, take the LCM here. 25 will be the LCM. 20, yeah, 25 will be the LCM, and 25 minus 13, you'll get the answer. Sorry, this is not 25, this is 52. That's why you're not getting the answer. This should be 52. Okay, even I am wondering from where did 25 come. We have total 52 cards. Now, out of total 52 cards, if we don't want heart cards, what is remaining? The other cards, the other 39 cards are remaining. So that will be the answer for selecting not a heart card. Understood the second one? Not a heart card, did you understand? There is a possibility of getting confused here. So did you understand, or you want me to repeat it again? You are expected to reply quickly. Okay, everybody understood? Yeah, good. Now, moving further, the third question. Let me clear the. Yeah. Now, read the question again. A card is drawn from a 52 from a pack of 52 playing cards. What is the probability that it is a club or red? So again, or is being introduced. So whenever you have or being introduced, you have to use the additional theorem. Okay, now either we will get a club card or a red color card. Anything we can get. We can get a club card or red color card. Now, club card is a set of 13 cards. If you take red cards, in red cards there are heart cards as well as diamond, which means total number of red cards are 26. Right? So C be an event of drawing a club. Now we are taking two different events. C is a event of drawing a club, and D is a event of drawing a red color card. So P of C, that is drawing a club card, is nothing but we have 13 club cards out of 52. So the possibility of drawing a club card is 13 out of 52. So you have 13 options. So you can pick any card from that 13. And then the event D. Event D is of drawing a red color card. Now, drawing a red color card, first of all, we have to check how many red color cards are there. Now, in the set, the red color cards are heart plus diamond, which is 13 plus 13, which is 26 cards. So out of 52 total cards, if you want to draw red color cards, then you have 26 options. It may be hearts, it may be diamonds. No, they have not mentioned about it. They have only mentioned about red color card. Okay, if it's club or a red color card, means for club cards we have 13 options, for red color card we have 26 options. But what is the total number of options are 52. So we know P of C, probability of getting a club card is 13 by 52. Probability of getting a red color card, that is event D, is 26 by 52. And in both of them there is nothing common. Now club card is completely different, red color cards are completely different. So there is nothing common, there's no common at all between these two. So there is no C intersection D. Okay, now let us apply this into the formula, that is P of probability of C union D is equal to P of C plus P of D minus P of C intersection D. So P of C, probability of getting a club card is 13 by 52. Probability of getting a red color card is 26 by 52 and minus 0. So since the denominators are same, just add the numerators. 13 plus 26 is 39 by 52. So the probability of getting a club card or a heart card is 39 by 52. Understood the C question? Any doubts in the question number C? Now, next question. The next question is, again read the question. See, every time why am I reading the question is each question that is given is separately solved. Okay, there's no connection between one to other. It's separately solved. That is why. A card is drawn from a pack of 52 playing cards, and what is the probability that it is queen or diamonds? Okay, so now they're asking us that they are drawing one card, and what is the probability of getting that one card as queen or diamond. Now how many queen cards will be there, we have to first check, and how many diamond cards will be there, we have to check, and after that only we will be able to solve the problem. Okay, now if you see this table, see, when it comes to cards, just make sure you write this table to one side of the paper, which is easy for you to understand. Okay, now every set of card, spade, club, heart, diamond, every set of card will have a queen in it, right? So there will be one queen in the spade, one queen in the club, one queen in the heart, and one queen in the diamond. So there will be four queens for totally 52 cards. Okay, and how many diamond cards are there? There are 13 diamond cards out of 52 cards. So define the event. P of, sorry, we finished until D. Now, event E will be drawing a queen card, and event F will be drawing a diamond card. So, event E, that is probability of getting event E, that is drawing a queen card, is 4 by 52, and probability of getting the diamond card, that is event F, is 13 by 52. Okay, now what is common in these two? What is common in these two? Queen card and diamond card. There is a queen card even in diamond card, correct? There is one queen card even in diamond card. So the common element is E intersection F is 1 by 52. I will repeat it again. Listen carefully, because you have something common here. You might get confused. Okay. So when it comes to, yeah, now they have asked us firstly to derive how many queen cards are there. So totally we have four queens, one queen in every set. Okay, so we have four queens out of 52 cards. Then this will be event E. What is event E? Drawing a queen card. Then coming to event F, that is getting a diamond card. That we have total 13 diamond cards out of 52 cards. So probability of getting event E will be 4 by 52, and probability of getting F F event is 13 by 52. Okay, we will be using a similar formula. Now we are supposed to see what is common between these two events. Now, the first event is drawing a queen card. So, queen is there in spade, queen is in club, queen is in heart, and queen is in diamond also. So, this diamond card also has a queen card. So, there is one queen card which is common in both diamond as well as the queen cards, right? So, E intersection F. I always told you common is intersection. So E intersection F is 1 by 52. Okay. Now 1 by 52, if you put that into the formula, you will get the probability. Okay, so P of E is the event of getting queen card, that is 4 by 52, and F is the event of getting diamond card, which is 13 by 52. And what is common between two? A queen card is common between both of them, that is 1 by 52, which is E intersection F. Now put that into the formula. P of E union F is equal to P of E plus P of F minus P of E intersection F. Okay, so 4 by 52 plus 1 by 52, sorry, 13 by 52 minus 1 by 52 will give you 16 by 52. So the probability of getting a queen card or a diamond card is 16 by 52. Did you all understand this? Any doubts in this part? The D question? Now, going to the last part, that is when a card is drawn from a 52 playing cards, what is the probability of not getting a spade? Now, in the first question, we understood how to draw a heart card and how to not draw a heart card. Okay, but here they have directly given, they have directly asked us to find out how to not draw a spade. Okay, in such questions of not drawing, you have to define two events. What are the two events? One event is about drawing a spade. So your next event, that is G, event G will be the event of drawing a spade, and event G dash will be event of not drawing a spade. So whenever they ask me, they ask ask one to pick the card, what is the guarantee that it is not a spade card? That is what they're asking us to solve. Okay, so we will be first finding out the G. Okay, that is the spade card, and then we will be checking out how to not draw a spade card. Now again, if you see the table, see table, if you have, it is very easy for you to analyze every question, especially for the cards. Okay, now how many spade cards are there in the 52 pack? So we have 13 spade cards in the pack of 52. See, 13 spade cards for the in the pack of 60, sorry, 52. So we have 13 spade cards out of 52. Now this gave us the spade cards. Now we have to find out not a spade card. Okay, so that is G dash, which is nothing but 1 minus P of G, that is 13 by 52. So the probability of not drawing a spade card is 39 by 52. Okay, so this is the final question and the answer of this particular problem. Any doubts in this problem? Please go through the problem once again. Check if you have any doubts. Understood? Yes or no? Okay. Now, the next question. Okay, good. Now, the next question. In an office canteen, 70% of the employees drink tea, 40% of the employees drink coffee, and 20% of the employees drink both tea and coffee. Find the probability that a randomly selected employee drinks either tea or coffee. So what is that you have to understand here in the final question is it says tea or coffee. Okay, in such questions of or that is being involved, always remember to use the formula. Okay, so let us define the events. Let A be the event of employees who are drinking tea, because first is given as tea, and then let B be the events of employees drinking coffee. Okay, now how many people are drinking tea? 70% of the employees are drinking tea. So 70% means 70 by 100. So 0.7 is the probability of people drinking tea. Similarly, people employees drinking coffee. So 40%. So 40 by 100 is 0.4. And how many of them are drinking both coffee and tea? So there are few common people who drink both coffee as well as tea. So that is intersection. When I say common, it is intersection. So A intersection B is 20%, which is 20 by 100. That is 0.2. Now, since we have all the required information directly given, so it is easy for us to just apply the formula and find out the answer, which is probability of employees drinking either tea or coffee, any one. Okay, either they will drink tea or they will drink coffee. Okay, now here if you see, put the formula P of A union B is equal to P of A plus P of B minus P of A intersection B. Now 0.7 plus 0.4 minus 0.2 will give you 0.9. So the probability of employees drinking either tea or coffee, any one of them they will drink, and that has been given here. Okay, a very easy question to solve. I hope that is clear to everyone. Okay, so the next question. A firm has 30 female employees and 40 male employees. So there are 30 female employees in a company and 40 male employees in a company. If two employees are selected at random, so this selection of employees is also important. If two employees are selected at random, what is the probability that, okay, what is the probability of getting two males, whoever two of them they have selected, what is the probability of getting two male people, and what is the probability of getting two female people, and what is the probability of getting one male and one female. Whenever you have and when you have questions which is talking about uh, you know mm, exact number of people in the organization or exact number of products, then use the combination. Okay, now this question you cannot solve in the formula directly, fine, because there is nothing common and they have not given you the clear picture of what is the event that has been happening. Okay, so out of 40 sorry, yeah, we have 30 female and 40 male, so 30 plus 40 we have 70 employees in a company, totally 70 employees. Out of total 70 employees they are selecting two of them, some for some reason they are selecting two of them. So that two whoever they select, we have to say them are what is the chance of them getting two male employees, what is the chance of them getting two female employees, and what is the chance of getting one male and one female. Okay, now let us define the event. Let event A be the selection of female employees and event B be the selection of male employees. So what are the total number of employees? There are 30 female and 40 male, so there are 70 employees in total in the company. Okay, now let us go to the first question. When they select two employees at random, what is the probability that both will be the male employees? Now, out of 70 people, we have to select two. Now, what is the possibility that two of them whom we select will be male only? Okay, so here what is the total number of male employees? We have 40 male employees. Out of that any two we can select. So 40 C2 divided by 70 C2, this is the favorable. We have 40 male employees, that is my favorable value for the male employees to come. And with the with the total number of employees being 70, now solve this. Now what is the formula to solve? N factorial divided by n minus r factorial into r factorial. So that is the main reason why we are supposed to use this formula and solve, because you're using combination. So 40C2 and 70C2, we have to use the formula to find out the value, and our final value of probability is 0.322. So did you all understand this problem? Only the first part which I have solved. Any doubts in that, or you want me to explain it again? Read the question and the first answer carefully. Do you have any doubt in that? Or understood? Okay. Now, since the first one was both are male employees, we took 40 as the number. Now, the second question is both are female employees. Okay, so since both are female employees, now how many female employees are there? We have 30 female employees. So out of 30 female employees, we are supposed to select two of them. Okay, random selection is done and the selection is done for two of them. So 30C2 divided by, what is the total number? 70. So 70C2. So the denominator will not change, only the numerator. Now we are selecting both of them as female employees. So both female employees, that is 30C2, will be the numerator. When you use the formula again, n factorial divided by n minus r factorial into r factorial, that will give you the full value of 435 divided by 2415, which is 0.18. Now, will you be able to solve that 30C2 and 70C2, or you want me to do that also? Will you solve it? Yes or no? Or you want me to solve? Reply fast. Okay. Seems like you're going to solve it. Okay. Now going to the next question, wherein we have one female and one male employee. Now, until now, we were considering two male in first question and two female in the second question. Now it is 1 and 1. So from 30 people of female, 1 is coming, and from 40 people combination, that is 1 is coming from here, 1 from here, 1 from here. Okay, so that is why 40C1 into 30C1 divided by, the denominator will not change, that is the full amount, that is full number of employees, that is 70C2. Out of 70 people, I am selecting two of them. In that two of them, one is male, one is female. Okay, now here they are saying us and. Since there is and, one female and one male, so that is why you have to consider multiplication. Okay, you're supposed to consider multiplication here. So 40C1 into 30C1 divided by 70C2. And if you solve this, you will get 0.496. So this is the next answer or the next question that we have solved. Any doubts in this? See, until you practice, you'll not be able to get it. Okay? Any doubts until here? Go through the questions that has been done until now.